So, in his theory of natural selection, Darwin proposed that evolution was inevitable. Throughout time, traits would arise, and when they suited the environment, they would survive. This process was how coral or any organism evolved. But it took a long, long time. And in the age of climate change, coral don't have that kind of time. So, how do we accelerate adaptation? Are there shortcuts we can harness to help coral change quickly? The answer relies on an understanding of the rules of inheritance. And not long after Darwin's death, another god of evolutionary biology would lay those rules out. His name was August Weismann, and in 1892 he proposed the presence of something he called the germplasm. This plasm was the material blueprint of an organism. Every trait, the whole shebang. And it existed inside the germ cells, sperm and egg. These germ cells carefully maintain themselves and the blueprint throughout an organism's life, allowing key traits to be passed down generation after generation. This immortal germline, as Weismann called it, was essential to any organism's survival. After all, if the blueprint wasn't protected, the species could be jeopardized. And Weismann even proposed the existence of a barrier between this germline and the somatic cells surrounding it, such that no matter what happened in the somatic cells, it wouldn't affect the blueprint. He called this idea the germ-soma barrier, and it had big implications for the speed of evolution, because it meant that adaptation was entirely determined inside the germline. A germline which was incredibly resistant to change over time. And that, Weismann insisted, was what made evolution ever so slow. So, a lot to chew on here, a lot of science talk. And if you're finding it hard to follow, it's probably because I barely understand it myself. But the key takeaway here is that under Weismann's rules, evolution is looking glacial, in part because any species' blueprint resists change by design, a fact which is problematic for coral given the ticking clock of climate change. But Weismann's story isn't done yet, and there was one other piece to his inheritance theory, something that could alter the germline enough to shift species quickly, and that was mutations. That's right. Even though the germline maintained itself carefully, rare errors in the blueprint would occasionally slip through. And when they did, they could yield new outcomes and make offspring fundamentally different from their parents. And while Weismann was working before mutations were proven, he, like many before him, firmly believed they occurred. After all, if the germline remained largely unchanged over time, what else did natural selection have to act on? Mutations, he presumed, were what really drove change, allowing for rapid adaptation. Of course, rapid is a relative term in the scope of evolution, and Weismann was by no means suggesting that mutations change species overnight. In fact, he believed the odds of a germline mutation taking hold to be exceedingly low, and that somatic mutations couldn't be inherited at all, since they were still subject to his barrier. So, even if beneficial mutations did exist, they had to occur in the germ cells to get passed down, while any that occurred in the somatic cells of the body would be lost on the next generation. So Weismann has really put us on a perilous cliff at this point, because if he's correct, coral's means of adaptation are looking very limited. Ideally, coral could update their firmware, so to speak, and pass beneficial changes arising outside the germline from one generation to the next. But in order to do this, they're gonna have to get around Weismann's barrier. Okay, so let's review everything we've learned up to this point. Absolutely not, I'm kidding, let's take a break. And when we come back, we'll stop talking about dead scientists and start talking about some living ones. Plus, we'll see why I had to tell you more about germ and somatic cells than you ever wanted to know, in a revelation about coral that is certifiably mind-blowing. So, stay tuned.